Alright, let's start section 1.2, simple random sampling. But before we actually talk about simple random sampling itself, let's talk about ways of acquiring the information. First and foremost, we can use a census, and that's where you um, obtain information for the entire population of interest. Now, a census may not be feasible for you. It can be one of the most time consuming and expensive ways to acquire information. So it tends to lend itself to other sampling methods, like experimentation, which is a controlled study that we can use to draw conclusions. But most sampling methods, uh, sampling is a method of acquiring information by choosing portions of a population in order to make inferences about the whole population. So there are many sampling techniques we'll actually get in the next section. We'll get to view 3 or 4 others. This section we're going to look at the most common, which is simple random sampling. Um, in a sample, when you're doing any kind of sampling method, you want a representative sample. And that's simply a sample that represents the population. I mean, that's what you want. Um, for example, if you use the percentage body fat of male marathon runners to draw a conclusion about the percentage of body fat of all adult males, that's unreasonable. I know it is for me. Um, my body fat, let's just say, is much higher than that of a marathon runner. I wouldn't want any comparisons of my body to be done to theirs. So with theirs, so that's not a representative sample. Um, Using the Hamptons, which is one of the richest places in the world to live, it's in New York, to make a inference about the income of the rest of the state of New York. Now, that's not representative either because think about it. You've got middle class people that live in Brooklyn, let's say, and you're using the income of the richest area to draw a conclusion about the middle class area is not going to work. That's just not going to work. And let's use something very basic. Internet web polling, like WTVA web poll of the day. Now you may think, yeah, that gets a sample of the whole viewing area, but you got to think a little more closely than that, because that would not be representative. There are some ways you can try to argue that it's representative, but if you just keep it basic, let's just think of it in a basic way. Does everyone have access to the internet right now? Most do, but there are some that do not. There are some people in the WTVA viewing area that still do not have access to the internet. So that's not going to be representative of your entire population. It's just not. It's only representative of the ones that have internet, but even more so, it's only going to be representative of the ones who even have internet that even care about getting on there and doing a poll. I mean, so you're not going to get a representative sample of everybody by doing a web poll like that. So just keep your mind focused, in a basic way on representative sample, because you'll have some questions about that. So make sure that you are familiar with that terminology there. Probability sampling. This is a basic kind of sampling, like tossing a coin to make a decision, or using a random number table or a bunch of random numbers to make a decision. Basically, what it does is it takes human error out of it. It takes the human judgment away. Um, um, so, so it's good in that fact that it will help you decide the members of a population and of a sample instead of using human judgment. And it's good because it guarantees that you're going to be able to use inferential statistics to draw a conclusion, because there's not that human judgment error in there. So you'll be able to take that information and draw a conclusion on it. But unfortunately, there are more efficient ways of sampling, and we'll get to a few of those a little later. All right, so the main emphasis of what we're doing today is simple random sampling. And this is where each object that you're sampling has the equal likelihood of being chosen. Okay, one of the most common simple random samples is putting papers in a hat and drawing out of a hat, drawing a number out of a hat. If you do that, that has an equal likelihood of being chosen. Okay, that's what we mean by a simple random sample. It has the equal likelihood of being chosen. Now, one thing I want to stress with simple random sample is this right here. Unless it says replacement is used, you want to assume that everything is done without replacement. I can't stress that enough. That's one of the most missed parts of simple random sampling that I see on a semesterly basis. Assume that it's done without replacement unless specified. Without replacement. Okay, so, for instance, here's the line of succession to the presidency. List 10 possible samples of size 2 that can be obtained from a population of 5 officials that we have above. Now notice it does not say replacement, so we're going to assume without replacement. So in this case, since it's size 2, VH and HV would be considered the same thing. We haven't given any kind of stipulation on order or replacement or anything like that. Okay, so we're going to assume those are the same things right now. So if we're doing a population of, of 10, okay, 10 samples of size 2, well, I'm going to start with the vice president, and that would be VH. That could be a sample size of 2. We could also have VP. We could also have VS, and we could also have VT. That's samples of size 2 of these 5, keeping the vice president the same. Okay, so those are all the samples of size 2 with the vice president being the same. Now let's assume the Speaker of the House is going to stay the same. Well, VH and HV are the same thing, remember, so we're going to say HP, HS, and HT. And if you forget about VH and HV being the same thing, once you write it out, just cross out your duplicates and you'll come out with the same answer we're about to come out with. Alright, so since PH and PV are the same, we're going to start with PS and PT. And the last one would be ST. So if you notice, we have 4, 7, and 3 is 10. So here's our samples, our 10 possible samples of size 2. Okay, 10 possible samples of size 2. Now, that's without replacement or order or anything like that. So VH and HV are the same thing. So that would be 10 possible samples of size 2. Alright, so let's look at the next one. So, if a simple random sampling procedure is used to obtain a sample of 2 officials, what are the chances that it's one of the samples in your first list? Well, there are 10 possible samples of size 2. So, there are 10 possible samples of size 2. So, we have a total of 10. So what are the chances that we're going to get one of the samples? Well, that would be 1 out of 10. Okay, that would be your chances to get one of the samples. Now, what are some ways to? It would be kind of like finding the probability. You have a partial over total. You're trying to find, it's what you're looking for, which is 1 sample, and we have 10 total samples that we just wrote out. So you would have a 1 in 10 chance of getting one of those samples with a simple random sampling method. What are some ways to obtain an SRS of size 2? Well, you could write them all out on a hat, put them in a hat and draw them out. You could you could use a random number table. You could use a random number generator. There are lots of ways. But the one that we're going to look at next is called the table of random numbers. The table of random numbers. And unless you're told a specific place to start, what you're going to do is randomly select what you're going to do is randomly select a number. Okay? We're going to randomly select a number like this one. Okay? And when you're picking your random number table, you want to go down the first column. Notice how we're going down this column. And then when you get done with it, you want to go back up the next column. Down, back up, down, back up. Now notice, we're looking at 3-digit numbers here, 0, 6, 9. So our next column would be 171. So that's why, if you notice, this box right here includes the first digit of the next column over here. That's because we're using 3-digit numbers for this particular example. So let's look at this. How to use a random number table. So here's the directions, so to speak. I tried to show you, but I may have confused you. So here's a written out version. So you want to number the units of interest. Okay? Number the units of interest. As I said, randomly select a starting point. I randomly selected starting point before was 069. So randomly select a starting point. Read down the column using the number of digits of interest. So in other words, if there are 50 units of interest, then you're going to use 2 digits. We used 069, so there were 3 digits of interest. For instance, if there are 451 units of interest, we're going to use 3 digits because 451. Record the numbers, discarding repeats and numbers outside the list of units. So, in other words, what you would do is you would go down that list. We would go down this list, and let's suppose here, just for the sake of having an example, let's suppose here that we have 100 numbers of interest. Well, that's 3 digits. Okay, that's 3 digits. So here's our 3 digits. We randomly selected 069. So I would go down through here, and I would select. Let's suppose I wanted a sample of 10. Well, I'm going to go down this column, up the next column, down, up, until I find 10 samples that are within 100. Okay, so they're in the 100. So, for instance, 069, that's 69. So 69 is in 100. It is between 0 and 100. Okay. 988, that's out of our range. 97, 097. 628, 9, 036, so that's 36. Keep on going, 024. All these other numbers are outside our range of 100. Now, when we come back up, notice we're using 3 digits here. So it's 84 and then 9, so that's 849. We have to use 1 digit from the next column to get our 3 digits. So go back up. And you would continue to go up and down the columns until you found 10 samples that were within 0 to 100. And so what you would do here, so we've got 69. So I would go to the 69th. I would go to the 69th number in the 0 to 100 and write it down. That would be because see, we have numbered our digits, okay? Our digits of interest. We've gone through there, and you may have all sorts of numbers, but you've numbered those things, or all sorts of categories, but you've numbered those things from 1 to 100. So you'll go through there and you'll find the 69th one. You'll write it down. You'll find the 97th one. Write it down. The ninth one. Write it down, and so on. And that would be how you would come up with your random generated numbers. Okay? Discarding any repeats and numbers outside the list of units. Okay, so Keno. In the game of Keno, 20 balls are selected at random from 80 balls numbered 1 through 80. Okay? Use Table 1 in Appendix A of your book to simulate one game of Keno by obtaining 20 random numbers between 1 and 80. Start at the 2-digit number in line number 5, columns number 31 and 32. Read down the column and up the next column. So, here we are. And so we're looking for numbers between 1 and 80, and we want the first 20 we find. We're going to start in line number 5, columns 31 and 32. Line 5, columns 31, and 32. So we're going to start right here at 86 because we're doing 2-digit numbers. So we are going to start line 5, columns 31 and 32. So right here is where we're going to start at 86. So we're looking for numbers between 1 and 80, and we want the first 20 we find. So that's not going to work. That's 86. Well, 39 works. 3 works. 97 is outside the range. 28 works. 58 works. 59 works. 81 is outside the range. 9 works. 36 works. 81 is outside the range. 52 works. 94 is outside the range. 24 works. 78 works. Then we want the next 2-digit column, which would be right here. 84 is outside the range, and we're going to start going up now. 57 works. 40 works. And you're going to keep on going until you get your 20 answers that you need for the game of Keno. So that is how, let me get it back up to our slide here. That is how you would use the random number table to select your 20 samples in that game of Keno. Okay, so now you're going to have several, or I say several, I think there's 2 of them, but you can randomly generate you some more. You can click similar exercise on your math homework, on your My Math Lab homework. You can click similar exercise and get another example to be able to work. But make sure you can read one of these random number tables. And one thing I would do to be able to practice this, you can make up your own example. Just decide on some numbers you want to choose in. Like, we used the numbers 1 to 80 for Keno. You could say, I want to use the numbers 1 to 150. And then I want to choose 5 in that range. And just pick your starting point and go down. It's very easy to practice the random number table. But make sure you know how to do that. And if you have any questions about it, please ask your instructor, because I know it's hard for me to explain that on a video. It's easier to be shown in person. And if you need that to happen, I'm sure you can come by and you can see me, or you can see your instructor, or you can go by the Student Success Center, and somebody will be glad to show you in person. But hopefully you understand it. It's pretty readable in your book, and there are tons of videos on it on YouTube. So feel free to go to YouTube and select that. But just beware. Some people use the random number table. Like our book uses it, and we go down a column, up a column. Some books go left and right. It's going to give you some random numbers, and it's correct to do it that way. It's just a matter of preference. and our book goes down and up. So keep that in mind as you're doing your homework. Make sure you're reading the directions so it doesn't say, make sure it doesn't say left or right. Make sure it always says down or up, okay? And if you have any questions, again, just ask your instructor.